So if I summarize what we learned so far in the matrices, we started with the definition of uh, matrices and then definition of rank. Then we learn how to solve a system of linear equation using row reduced echelon form. Then we combined the idea of rank and the consistency of system of linear equations. And then we uh, introduced the concept of eigenvalues and eigenvectors, and then diagonalization, similar matrices, followed by diagonalization of symmetric similar matrices. So that was all we should supposed to study in this matrices portion. Now we will start calculus. So in calculus, because in your plus two, you have already learned many things in calculus like differentiation, integration, and application of integration. So, but here our focus would be to enhance or extend that idea from one variable to multiple variables. So let us see how we can do that. Okay, so let us first try to understand what we understand by function of several variables. Let me first share the screen. I hope the screen is visible. So I'm beginning in few moments. Okay, all right. So let's start with the uh, idea of function of several variables. Function of several variables. So if I recall, whatever studies you did in your plus two, you always studied about the function y equals to f of x. So where f is a function from, if it is a real valued function from R to R. So only a single component input was given to the function f. But here if I try to extend this function, suppose f from say R2 means R cross R to R. So how it will look like? It will look like f of not two components, x comma y. So here we can call it like z is a function of x and y. Similarly, I can extend the idea from f from Rn to R. So how it will look like? It will look like z equals to f of x1 comma x2 comma xn. So this is how we can extend the idea of function of several variables. We'll define it formally by writing its definition. So a real valued function, a real valued function defined on D, which is a subset of Rn, and Rn is nothing but this set x1 comma x2 comma xn such that xi belongs to R, which assigns each member of T, which assigns each member of D to a unique real number z equals to f of x1 comma x2 up to xn is called the function of several variable, is called the function of several variables. Here x1 x2 xn are independent variables and z is dependent variable, like y equals to fx, x is independent and y is dependent variable. So this is the definition of function of several variables. We are going to discuss only here real valued functions, means whose domain and codomain both are real numbers. We can write an example of function of several variables. The possible example would be z equals to f of xy y comma t. This is equal to x square plus y square plus t. Is a function of three variables, and geometrically this function maps the point xyz onto the real line. Okay, so in this way you can define more functions. Z equals to f of say x1 comma x2. This could be sine of x1 plus x2. So basically what is happening, if I try to connect it with the geometry, for example with the second function, this example, so what it does, it picks any point from the Cartesian coordinate system and it maps it onto a real line. That is what we mean function is defined from R2 to R. And in the first example, what is happening, we are taking a point in the space and it is being mapped onto a real line depending on the definition of the function. So this is how we should understand the definition of function of more than one variable or simply function of several variables. Now there is a definition called level curve. Level curve. Let z equals to fxy be a function of two variables. Let z equals to fxy be a function of two variables. The set of points which satisfy the set of points set of points which satisfy fxy equals to c is called the level curve. Is called the level curve. So if I try to explain this idea, suppose if I take an example, z equals to x square plus y square. So if I try to explain its geometry, suppose this is three-dimensional Cartesian coordinate system. This is say x-axis, this is y-axis, and this is z-axis. So how this z equals to the surface of this z equals to x square plus y square will look like? It will be a function whose shape will look like this. Like a paraboloid. You take a parabola along z-axis and just rotate it about the z-axis, so it will create a bowl kind of shape. So this is how this z equals to x square plus y square looks like. So what the if I want to look a level curve in this particular surface, so what I can do, suppose I'm taking a plane z equal to say 1. So when this z equal to 1 plane will intersect this surface, so what would happen? The point of intersection will be this kind of curve. So this curve is actually a level curve. Okay, means in this whole surface there are infinitely many level curves, and it is one of them. You keep on changing the value of z, you will get different level curves. This is how one should understand the definition of uh, level curves. Okay, similarly, if I take a function z equals to fxy, fxy, I should write like this: z equals to fx1, x2 and x3. And now if I try to do the same thing, f of x1, x2, x3 equals to some constant c, so then this will be called as a, because this is going to be some function, and if I take the same thing as we did for the previous example, so what will happen? This is called the level surface. Okay, so these are the definitions of the level curve and level surface. Now the most important thing in calculus, the idea of limits and continuity. So if you recall the concept of limit which you have learned so far, so what it says that if I talk about the function y equals to fx, or you might be familiar with this idea, limit x tending to a f of x equals to L. Okay, so when it is equal to L, so you got three criterions, and what the one of them was left hand limit, right hand limit, and then functional value. So what you evaluated basically, LHL, that is limit x tending to a minus f of x is L, and RHL, that is limit x tending to a minus a plus f of x equal to L. So if it is happening for any function y equals to fx at point x equals to a, then we say at x equals to a, the limit of the function fx is L. So this is what you have done so far in your +2 classes. But if I try to see it geometrically, so suppose this is a portion of x-axis and this is the point A, and suppose this is the architecture of y equals to fx, how this function looks like in space, basically in plane. So x tending to a means if we are approaching from x tending from the left hand side or from the right hand side to this point, we are basically getting the same point. Okay, means whenever this x is approaching to a from the left hand side and x is approaching to a from the right hand side, the point which we are getting on top of the curve, means on the function, that is particularly this point, it is actually L. Then this is how we say the function has a limit at x equals to a and it is L. So this is how you have done in your +2, and you have evaluated the limits whether they exist or do not exist, depending on whether this LHL and RHL are matching or not. But if I extend this idea, for example, instead of taking a function y equals to fx, if I take a function z equals to f of xy, means I have taken a function of two variables. Listen carefully, this is a very crucial point to understand. Many students fails to understand this. So what we are going to do here, we are going to analyze the same situation. Means if I try to look for this situation, limit x comma y tending to, I'm just trying to replicate this thing, x comma y tending to a comma b such that f of x comma y equals to L. So when it happened to be a single variable case, we know the idea how we can evaluate the limit and what was the cases when limit was not existing. But if I have, once I have extended this idea, limit xy tending to a comma b, means I made it from one variable to two variable case. So now what should be the criterion? How should we get and how should we ensure that the limit of this fxy when xy is approaching to a comma b is L? So let us try to do the same thing. Let us try to do the same thing how geometrically we understand and understood this scenario of limit x tending to a fx equals to L. So now in the first case the domain was only x-axis, but in the later case when we have two variables, so basically we are dealing a function that is defined from R2 to R. So it means what? R2 is a plane. So definitely the domain of the function is some portion of this plane or some subset, or it may be completely R2. So like here we draw the domain. The domain was basically this x-axis only. But for the second case, when it got two variables, if I try to draw the domain, then domain is going to be, suppose this is z-axis, x-axis and y-axis. Okay, so this is the suppose point a comma b. Okay, so if I exactly try to use the same idea which we used in the single variable case, means the idea of left hand approach and the right hand approach. So if I try to do the same thing for this point a comma b, because same thing should happen here as well, means if I'm approaching to a comma b, then suppose fxy has this geometry, because this time it may be a surface kind of this. So at this, suppose this is the point whose numerical value is L. Okay, so but if I try to use the idea of LHL and RHL, then it is going to be a challenging thing, because here when the function was a single variable function, we had only two ways to approach to this point A, either from the left or from the right. But now if I try to approach a comma b, we have infinitely many ways to do that. Like one can come from here, one can come from here, one can come from this direction, or one can come from this direction. And basically these are infinitely many ways to approach this point a comma b. So it means what? The idea which we have developed for evaluating the limit of single variable function is not going to help us in the two variable case, because the ways, the number of directions from which we can approach to the point a comma b in the two variable case, it is going to be infinitely many. So if I try to exactly use the previous idea, I need to check all the ways, which is practically impossible. So it means what? We should look for a more general way where we can avoid this path kind of a structure, means LHL or RHL kind of a structure, and which can help us into any dimensions, whether your function is a two variable, three variable, or in general n variables. So now that is why we are going to define a formal definition of limit, which is actually a very fine concept. I urge you all to stay focused, because it's it's very deep to understand, and usually students miss to get it. So I hope it is clear why we are going to define a very more general definition of a limit, which we are calling as a formal definition of limit, and that definition will be applicable to the single variable case as well. Formal definition of limits. Formal definition of limits. So limit of fxy. So basically we are talking about limit x comma y. We'll define it for two variable which can be generalized for any variable. X naught comma y naught fxy equal to L means when we would be able to say that the limit of x fxy at x naught comma y naught is L. This is what we are going to write. Limit of fxy limit of fxy approaches to L approaches to L when x comma y when x comma y approaches to x naught comma y naught and it is represented as and it is represented as limit x comma y tending to x naught comma y naught fxy equal to L. If now this is the crucial point which you should focus very carefully. If for every, this is a symbol for every means for all. If for every epsilon greater than 0, this is a symbol for there exists. There exists delta greater than 0 such that mod fxy minus L is less than epsilon whenever mod x we can write like this under root x minus x naught whole square plus y minus y naught whole square is less than delta. ओके सो पहले ये डेफिनेशन हम समझते हैं केयरफुली कि व्हाट आई हैव जस्ट रिटन व्हिच सीम्स वेरी वेरी अनयूजुअल. सो इफ आई टेक एन एग्जांपल, हम एक सिंगल वेरिएबल का केस लेते हैं, उससे हम समझेंगे कि ये डेफिनेशन का मतलब क्या है एंड हाउ इट वर्क्स. सो बेसिकली इफ आई राइट the same definition for a single variable case, then means suppose we have a function y equals to fx. Okay, so if I try to write the single variable case, so how it would look like: for every epsilon greater than 0 there exists delta such that mod fx minus L, means we are writing the definition for the same this abstract definition for single variable case. x tending to x naught, f of x equals to n. ओके, तो इसको हम समझेंगे कि ये इस चीज को हम LHL और RHL के अलावा इस डेफिनेशन से कैसे समझ सकते हैं. Then if it is clear to you, then we can enhance that idea for any dimension or any number of variables. So what it says, for every epsilon greater than 0, I'm not writing here, just reading it. For every epsilon greater than 0, there exists delta greater than 0 such that mod fx minus L less than epsilon whenever under root x minus x naught whole square is less than delta. Okay, so equivalently we can write this statement. This is in place of this we can write particularly this thing, mod x minus x naught less than delta. ओके, तो इसको थोड़ी सी इसकी ज्योमेट्री हम समझते हैं कि हाउ ज्योमेट्रिकली इट विल लुक लाइक फॉर सिंगल वेरिएबल केस. सो if you carefully see, suppose let's take a particular example. ये आपका y axis है और ये आपका x axis. Okay, and suppose y equals to fx is this function. This is y equals to fx and this is the point x naught. Okay, so if you carefully see these inequalities, so this mod x minus x naught less than delta, if you solve it, what you will get? If you solve mod x minus x naught less than delta, you will get x minus x naught greater than delta, less than delta, and greater than minus delta. So if you further solve it, x less than x naught plus delta greater than x naught minus delta. So basically we are defining an interval x naught minus delta comma x naught plus delta. So if I try to draw this interval, this interval will look like something this. This is say x naught minus delta and this is x naught plus delta. Okay, and if you solve this inequality, mod fx minus L less than epsilon, what you will get? You will get mod fx less than L plus epsilon and greater than L minus epsilon. Okay, so suppose this is the point L. Okay, so if I try to see it, it would be on the y-axis. Okay, this is the point L, and now we are also having an interval on y-axis that is L plus epsilon, and here it is L minus epsilon. So see what it says. Now let's try to see the whole scenario like this. Let me change the color of. So if I try to draw the pre-image of this region, so how it will look like? Let me change this function a bit like this so that the image can be in the frame. Suppose this function is going like this. Okay, I just did it so that we can visualize the same in the specified frame, otherwise it will go outside. So if I try to see the pre-images of this interval L, listen carefully because it's very crucial concept. If I try to see the pre-image of this interval L plus epsilon and L minus epsilon, what would be this? Just draw this arrow and draw this arrow. So basically, if you carefully see what is happening, each and every member of this portion of x-axis which is inside the interval x naught minus delta and x naught plus delta, it is being mapped where in the interval L minus epsilon and L plus epsilon. Okay, so now what definition says? Definition says for every given epsilon, okay, for every given epsilon means we have a choice to choose any positive number. Okay, for every given epsilon greater than 0, there exists a delta such that whenever this mod fx minus L is less than epsilon, you are able to discover a delta such that this is true, this statement is true when this is happening. So what would happen? You just try to imagine you keep on choosing the value of epsilon is smaller. What will happen? This interval will become more precise. And in that case, how it will look like? It will look like this. Now just keep on doing precision with the value of epsilon. What will happen if you choose a epsilon very significantly small? What will happen? You are going to get an interval which barely covers L only, and its pre-image is what? X naught. So this is what if it is happening, means if we are getting such combination of epsilon and delta, then it ensures that limit of fx at x naught is L. So this is how, see here, we do not use any LHL and RHL kind of concept. And we can extend this idea. We can extend this idea in two variable case, because if I go with the two variable, then what would be the changes? The changes will be the domain will become a plane instead of a line, x naught comma y naught. And then what you need to do, instead of taking in an interval, here we can take a circle, and then we can take its images on the function or simply on the z-axis. So this idea we can extend for any number of dimension. We can write here f of x1 comma x2 comma xn minus L less than epsilon whenever this mod x minus x naught y minus y naught, whatever number of variables are there, this is true. Okay, तो एक एग्जांपल हम इस पे करते हैं, because this is not very easy to understand. Then probably you will get something. Okay, so let us take this example. Limit x comma y tending to 0 0 x square y upon x square plus y square plus 1. Okay, so if I try to evaluate this limit, we will use the same concept. In the body of the function, just put the values of x and y, and how it will look like: 0 square into 0 upon 0 square plus 0 square plus 1, which is 0. Okay, so if you are able to compute the limit by directly substituting the limit point in the body of the function, then that's a direct way. But it was an easy example where we can evaluate it directly. But on the other hand, if I take another example, say limit xy tending to 0 0, limit xy tending to 0 comma 0, 2xy square, 2xy square upon x square plus y square. Okay, so now I'll be taking your queries here at this point, but I would like to ask a simple question. For the first example, it was easy to find the limit, but if I need to find the limit of second example, so if you try to put in the body of the function 0 comma 0. So what would happen? It is going to give you 0 by 0. So what should be our approach to find the limit? This is my question, and you must be having many queries, and I will be answering you. Keshav, बताइए. So this concept is not complete. We'll do this example with the idea which I have explained today, but since we are going to finish our time, so that is why I'm stopping here and taking your queries. Okay.
Excuse me, sir.
Yes, वैभव बताइए.
सर जो आपने पहले बताया था लाइन ऑफ कर्व एंड लाइन ऑफ सरफेस, दोनों में डिफरेंस क्या है?
नहीं, लाइन ऑफ कर्व में क्या है? अगर सपोज आपके पास कोई कोन है, ठीक है, जैसे कोनिक्स कर्व आपके कैसे बनते हैं? आप कोन को प्लेन से डिफरेंट डिफरेंट एंगल से कट करते हो, तो उस कोन का और जो प्लेन का इंटरसेक्शन होता है उसे क्या बोलते हैं आप? उसी से एक कर्व क्रिएट होता है.
यस
ठीक है. तो अगर आप उस कोन को किसी एक प्लेन से कट करते हो z इक्वल टू c से, ठीक है, तो उस प्लेन और कोन का जो इंटरसेक्शन होगा इट विल गिव यू अ कर्व.
यस सर.
उसी कर्व को हम लेवल कर्व कह रहे हैं. अब कोन की जगह आप इन जनरल कोई भी सरफेस ले सकते हो, एंड यू टेक अ प्लेन z इक्वल टू c एंड टेक इट्स intersection, whatever curve you will get, it is called the level curve. And on the other hand, when it comes with level surface, तो लेवल सरफेस में आपके पास फंक्शन क्या है? इनिशियल z इक्वल्स टू f x y t या f इक्वल्स टू x1 x2 x3. उस केस में क्या है कि
दो वेरिएबल से ज्यादा हो जाएं जब,
हाँ, दो वेरिएबल से ज्यादा हो जाएंगे तो we cannot see it geometrically, because to see it geometrically we will be requiring one more axis, x y z, और एक एक्सिस हमें और चाहिए होगा. जैसे जब आप प्लेन में किसी कर्व को ड्रॉ करते हो तो उसमें दो एक्सिस होते हैं ना, एक इंडिपेंडेंट एक्सिस, एक डिपेंडेंट एक्सिस. ऐसे ही जब आप z इक्वल्स टू f x1 x2 x3 को प्लॉट करने का सोचेंगे तो you will be requiring first three axes x1 x2 x3, then one dependent axis z, but we are not trained to do so we won't be able to see it geometrically. So but what we can see, if we take z equal to c, then in that case what will happen? You will get a particular surface. For example, suppose z equals to I take example z equals to x1 square plus x2 square plus x3 square. Okay, and now but if you try to see it geometrically, it's not possible. It's impossible, almost impossible, very difficult. But if I take z equal to c, then what will happen? You will get x1 square plus x2 square plus x3 square equals to c, and it is an equation of what? It is an equation of sphere. So this sphere is actually a level surface of z equals to x1 square plus x2 square plus x3 square. I hope you got it.
Yes sir, yes sir. Thank you sir.
Vaibhav Ganesh.
Sir, can you explain the precise definition again, sir? समझ नहीं आ रहा.
ये एक बार में नहीं समझ में आएगा बच्चे. इट्स नॉट दैट इजी. मैं थोड़ा सा एक्सप्लेन करता हूँ फिर से. हम कर क्या रहे हैं कि ये पिक्चर आपको दिख रहा है, वेयर माय कर्सर इज मूविंग राइट नाउ?
यस सर.
ये जो इनइक्वालिटी मैंने लिखी हुई है सिंगल वेरिएबल के केस वाली, mod fx minus l less than epsilon whenever mod x minus x naught less than delta, इसको ज्योमेट्रिकली आप समझो. हम क्या रहे हैं कि अगर हम कोई एक एप्सिलॉन चूज करते हैं, ठीक है, और पॉजिटिव एप्सिलॉन, तो mod fx minus l हमेशा एप्सिलॉन से छोटा होगा अगर हमें एक डेल्टा मिलता है, such that mod x minus x naught is less than delta. Means this is true. Epsilon is any real number, any real positive number. Okay.
तो सर ये हर पॉजिटिव नंबर से
आप इसको ज्योमेट्रिकली समझो, एंड दिस इज अ वेरी डीप कॉन्सेप्ट. लिसन मी केयरफुली, आई एम गोइंग टू एक्सप्लेन इट अगेन. ये जो यहाँ पे पिक्चर मैंने ड्रॉ किया हुआ है, हमने एक इंटरवल ड्रॉ किया एल के अराउंड वाई एक्सिस पे, और सिमिलर इंटरवल ड्रॉ किया एक्स नॉट के अराउंड, जो आप देख पा रहे हो पिक्चर में। और ये इंटरवल हमने ड्रॉ कैसे किए हैं? ये इंटरवल हमने ड्रॉ किए हैं ये दोनों इनइक्वालिटीज को सॉल्व करके। ओके, दिस इनइक्वालिटी एज वेल एज दिस इनइक्वालिटी। And now what we are saying, I'm saying for any epsilon greater than 0. So it means we have the flexibility to decide the length of this interval. Okay. So what it says, अगर हम L के अराउंड कोई भी इंटरवल ऐसा लेते हैं, ओके, सो दैट हमें एक डेल्टा जरूर मिलता है जिसका कि जब भी हम इसकी प्री इमेज यहां पे देखेंगे तो वो उस इंटरवल के अंदर कंटेन्ड हो। ओके, अगेन आई एम
Okay, sir.
रिपीटिंग, मैं क्या कह रहा हूं, हम L के अराउंड कोई एक इंटरवल पिक करते हैं किसी भी लेंथ का। ओके, अब अगर हम इसकी प्री इमेज हम देखते हैं, प्री इमेज देखने पे हमें एक्स नॉट के अराउंड हमेशा एक इंटरवल मिलता है जिसमें कि इसकी प्री इमेज कंटेन्ड हो, तो ये इसकी लिमिट जो है L होगी। और अगर ऐसा नहीं होता है तो लिमिट L नहीं होगी। इसका नहीं होता है का केस हम देखेंगे इन द नेक्स्ट लेक्चर।
Okay, sir. Thank you.
रंजन कुमार, ईशा,
टेबल लिखे हैं इसका सबसे वो आर
वन बाय वन। रंजन फर्स्ट।
सर वो आर आर रेज़ टू पावर एन है या जेड लिखे हुए हैं?
आर रेज टू द पावर
जेड है या एन है सर?
आर रेज टू द पावर एन है कहीं
ये सर
Here?
जेड है या
ये बात कर रहे हो, ये n है, दिस इज n फॉर नो नंबर।
सर इसके ऊपर वो वाला सर आई आर लिखते हैं या आर होता है केवल?
नहीं, ये आप ओके, आई फॉरगॉट टू मेंशन, ये हमारा इंग्लिश का सिंपल आर है। ओके, आर लेटर है, बट इन मैथमेटिक्स व्हेनेवर वी वांटेड टू रिप्रेजेंट सेट ऑफ रियल नंबर्स तो उसके लिए सिंबल है, ये लाइन 2 बार आती है। ठीक है, दिस इज a symbol फॉर सेट ऑफ रियल नंबर्स। ठीक है,
यस, तो वो ये सर वो आर स्क्वायर लिखे हैं ना उसके, ये आर आर इम्प्लाइज
हाँ
आर के नीचे आर आर।
हाँ, दिस इज आर स्क्वायर, मतलब आर क्रॉस आर।
ओके सर, थैंक यू।
ईशा,
Sir, you told that in order to find out the limit of f x comma y, we can approach that particular point from infinite directions. So, but in case of circle, if we choose any point within that circle, for that point even we can approach it from infinite directions. So, what's that significance of choosing circle? I didn't understand that.
no, I didn't follow your question. You said I just said if we are having two variable function, in that case, if I try to imply the same definition of single variable, so there won't be only LHL and RHL. There would be infinitely many ways. So if I have to find the limit by that approach, then I need to evaluate the limit from all the directions, which is not practically possible. That's why we are stopping use of this particular approach. Now, what is your question?
So I got it. So one more doubt, sir. On page 17, I didn't last part.
Yeah,
Slide
last.
17. Yes, sir, this triangular part, this pyramid type, that shape.
This one?
Yes, sir. So what did you tell while explaining this?
I told you that जैसे R से R में मैपिंग का मतलब क्या है? If I am writing a function which is defined from R to R, so geometrically if I want to see it, so it means what? We are picking a point from a line that is x-axis and mapping it on the line that is again x-axis. बट अगर R2 से R में जा रहे हैं तो इसका मतलब क्या है कि हमारा डोमेन अब प्लेन है, तो वी आर पिकिंग अ पॉइंट फ्रॉम अ प्लेन एंड मैपिंग इट ऑन टू a straight line or simply x-axis. और अगर यही R3 है तो R3 में ये आपका x एक्सिस हो गया, ये y एक्सिस हो गया, ये z एक्सिस हो गया। इसमें कोई एक पॉइंट हम पिक कर रहे हैं। तो if we are looking for a function which is defined from R3 to R, so it will be mapped from three-dimensional point to onto some point on the x-axis. This is what I explained.
So mapping itself is taking the image of that particular point on that geometrical figure.
No, suppose मैं एक example दे देता हूँ आपको, that would be easy. Suppose we have this example, f of x comma y comma z equals to x plus y plus z. ठीक है, तो अब मैं आपसे अगर पूछूं f of 1 comma 1 comma 1 की इमेज क्या है, तो ये कितना होगा? 3. ओके, इट मींस व्हाट? अब 1 comma 1 comma 1 को अगर मैं थ्री डायमेंशनल स्पेस में लोकेट करूंगा तो सपोज ये यहाँ पे है 1 comma 1 comma 1, जो ये रेड डॉट है, ठीक है। तो अब इस मैपिंग का ज्योमेट्रिकल मतलब क्या हुआ कि ये थ्री डायमेंशनल स्पेस से हमने इस पॉइंट को पिक किया, और ये एक्स एक्सिस पे, क्योंकि 3 तो जस्ट अ नंबर, तो ये कहां से बिलोंग कर रहा है? सेट ऑफ रियल नंबर से बिलोंग कर रहा है। सेट ऑफ रियल नंबर मतलब रियल एक्सिस और सिंपली एक्स एक्सिस। तो ये सपोज ये पॉइंट अगर आपका 3 है, तो ये थ्री डायमेंशनल स्पेस से पॉइंट 1 comma 1 comma 1 लिया, वो मैप कहां पे हो रहा है? 3 पे हो रहा है। ये जस्ट यू कैन इमेजिन इट एज एक्स एक्सिस।
So, but
और
this 3 can be plotted even on y-axis or z-axis, even this 3, because it's not
no,
specified.
they are independent. I just took an example of x-axis. It is not required that you should imagine it like a only x-axis. You can just call it as a real line. We call it as a real line because there is no difference between x-axis and y-axis and z-axis independently. Both are just a simple, all of them are simple real lines. Okay.
So basically, this 3 can be plotted on any line, any real line, real axis.
Any real, it's just a real line. इसमें एक ही एक्सिस है। आप फंक्शन के डोमेन और रेंज को आइडेंटिफाई करो ना। डोमेन में क्या है? डोमेन इज R3 एंड रेंज इज R. R का मतलब क्या है? R इज जस्ट अ रियल लाइन। आप उसको एक्स एक्सिस इमेजिन करना चाहो एक्स एक्सिस इमेजिन कर सकते हो, वाई एक्सिस इमेजिन करना चाहो वाई एक्सिस इमेजिन कर सकते हो। ठीक है।
Yes, sir. Thank you, sir.
Too many questions. This class is over. Those who want to leave, they can leave. Paramveer Singh.
Sir, the properties that we studied for one variable, will they be valid here also for 2, 3, and
They will be valid, but they won't be able to help you to get the
sir,
get.
like the question you gave us right now, will we be able to solve that using L'Hospital rule?
एल हॉपिटल रूल आपने, मैंने तो बताया नहीं अभी, बट अब आपने इसका जिक्र कर दिया है, तो एल हॉपिटल कैसे लगाओगे आप, इसमें बताइए।
So that we can first differentiate with respect to x and keeping y constant, then with y keeping x constant.
इस टाइप के फंक्शन में कभी आपने एल हॉपिटल रूल लगाया है जहां पे
No,
न्यूमरेटर और डिनोमिनेटर में दो वेरिएबल हो?
no sir.
तो आपका जो एल हॉपिटल रूल है वो सिंगल वेरिएबल के लिए ही डिफाइंड है, मल्टीपल वेरिएबल के लिए डिफाइंड नहीं है।
Okay sir.
ओके, दिव्यांश।
सर जो सर डेल्टा है सर वो
हाँ।
टेंस टू 0 ही होगा ना सर?
नहीं, टेंस टू 0 का मतलब कुछ नहीं है। सिंपल आप डेल्टा को समझो कि जिस पॉइंट पे हम लिमिट इवेल्युएट कर रहे हैं उसके अराउंड एक इंटरवल क्रिएट कर रहे हैं। एंड ऑब्वियसली जब आप अपसाइलन को बहुत कम करते जाओगे, जो एग्जांपल हमने पिक्चर में शो किया, अपसाइलन को कम करते जाओगे तो डेल्टा भी नेचुरली कम होता ही जाएगा। और अगर ऐसा नहीं हो रहा है तो लिमिट एग्जिस्ट नहीं करती है। इसका हम एग्जांपल भी देखेंगे।
पर सर चीज समझा नहीं सर, हम लोग सर एप्सिलॉन पे क्यों सर डिपेंड कर रहे हैं सर? हम लोग तो डेल्टा पे डिपेंड करना चाहिए, तब तो सर फंक्शन की वैल्यू सर वो वेरी करेगी।
नहीं, दोनों पे डिपेंड करेगा। और बट अपसाइलन विल बी इंडिपेंडेंट एंड डेल्टा विल बी डिपेंडेंट। ओके
सर पर सर एप्सिलॉन तो सर उसकी फंक्शन की सर वैल्यू के लिए वो है ना सर, डिफाइन कर रहा है।
फंक्शन नहीं, फंक्शन की वैल्यू जिस इंटरवल पे मैप हो रही है, उसके अबाउट जिस पॉइंट पे मैप हो रही है उसके अराउंड एक इंटरवल क्रिएट कर रहा है एप्सिलॉन।
सर एप्सिलॉन नॉट है क्या सर?
Epsilon is just a number like 0.1, 2, 3, whatever you can take. Any real positive number. Okay. Basically हमारा एम यही है कि जो पॉइंट है लिमिट, फॉर एग्जांपल कैपिटल एल, उसके अराउंड हमें एक इंटरवल ड्रॉ करना है, और उस इंटरवल की लेंथ चाहे जो भी हो उसके अकॉर्डिंग हमें एक्स एक्सिस पे भी, मीन्स जहां डोमेन है जिसपे हमारा पॉइंट अप्रोच कर रहा है उसके
जी
अराउंड
सर।
भी एक इंटरवल मिलना चाहिए जिसमें कि इसकी पूरी इमेज प्री कंटेंट हो। इंटरवल मिलना चाहिए, व्हेन आई से इंटरवल मिलना चाहिए मतलब वो डेल्टा हमें मिलेगा तभी तो इंटरवल मिलेगा। अगर वो इंटरवल नहीं मिलेगा तो लिमिट नहीं एग्जिस्ट करेगी।
यस सर।
इस पे मैं और बात करूंगा बिकॉज इट्स नॉट इजी एंड वी आर गोइंग टू सी इट वेरी फ्रीक्वेंटली, तो इस पे आई विल टेक एनफ टाइम टू मेक ऑल द क्वेरीज वेरी क्लियर। सार्थक,
पेज नंबर 18 निकाल।
सर
वैभव आपका क्वेश्चन मैं ले चुका हूं, आप अब नेक्स्ट लेक्चर में पूछना। लेट मी फिनिश विद अदर वन। सार्थक,
तो सर पेज नंबर 20 पे जाना एक बार।
हाँ बताइए।
सर इसमें आपने कहा कि जब L प्लस एप्सिलॉन एग्जिस्ट करेगा तो उसके कॉरस्पॉन्डिंग हमें x नॉट प्लस डेल्टा चाहिए।
हाँ,
तो सर अगर
इसमें से
हाँ,
एल और नहीं, इसमें से एल और एक्स नॉट तो है ही, जो नई चीज हो रही है वो
हाँ वो
एप्सिलॉन और डेल्टा।
ये सर अगर हमें डेल्टा नहीं, अगर हम डेल्टा पता है और उसके कॉरस्पॉन्डिंग एप्सिलॉन नहीं पता है तब भी तो लिमिट एग्जिस्ट नहीं करेगी, कह सकते हैं हम?
नहीं, देन आई थिंक इट वोंट बी वैलिड, क्योंकि ऐसा हो सकता है कि आपने क्योंकि एल हमने जो चूज किया है इट इज चूजन इन सच अ वे कि एल प्लस अपसाइलन और एल माइनस अपसाइलन, ताकि ये एल को कवर करे। बट अगर आप डेल्टा से लेके चलोगे तो हो सकता है इसकी इमेज ऐसी जाए जो एल को कवर ही ना करे, ये भी तो हो सकता है।
तो सर हम वैसे उल्टा नहीं कह सकते कि अगर एप्सिलॉन हमने लिया तो वो x डॉट को कवर ना करे तब?
नहीं, उल्टा हम नहीं कह सकते हैं। आई विल शो यू एग्जांपल इन मे बी इन नेक्स्ट लेक्चर, जहां पे मींस ऐसा नहीं है, हम अपसाइलन और डेल्टा को रिप्लेस नहीं कर सकते कि जो काम अपसाइलन कर रहा है वो डेल्टा करने लगे, जो डेल्टा कर रहा है वो अपसाइलन करने लगे, देन इट विल फेल।
ठीक है सर।
अर्शप्रीत सिंह।
सर जो आपने क्वेश्चन दिया था एंड में,
हाँ जी,
सर उसे हम a sin थीटा a cos थीटा मान के कर सकते हैं, नीचे 1 बन जाएगा और डिनोमिनेटर में।
एक्स को 1 ले लो, वाई को 2 ले लो, हो गया सॉल्व।
सर वो वेरिएबल के फॉर्म में ले लेंगे, थीटा के वेरिएबल में।
आप क्या लोगे, आप पहले बताइए फिर से।
a sin थीटा x को और y को a cos थीटा।
तो आपने ए कांस्टेंट है,
हाँ जी सर।
तो फिर तो आपने 2 वेरिएबल को सिंगल वेरिएबल में कन्वर्ट कर दिया। थीटा
हाँ,
ए देन रिमेन्स ओनली वेरिएबल।
ओके सर।
ऐसा भी कर
तो
सकते हैं,
एक
यू वुड हैव चूजन x इक्वल्स टू r cos थीटा एंड y इक्वल्स टू r sin थीटा,
हाँ एक
देन
वेरिएबल।
दैट केस ऐसा पॉसिबल हो सकता है कि इसकी लिमिट आपकी निकल जाए, बट हम शॉर्टकट नहीं चाहते। वी आर लुकिंग फॉर अ वेरी कॉन्क्रीट मेथड जहां से हमें
ओके
कोई डाउट ना रहे, ठीक है। बट
ओके सर।
दैट इज एन अप्रोच जहां पे अगर इन अ हरी यू वांट टू सी द लिमिट यू कैन डू। Okay.
ओके सर।
Okay, that's all for today. See you next week.